Good morning, students. Today I, Jeevan Kumar Pandey, once again welcome you all, the students of Standard 9th of DAV Public School Gumla, to the next lesson of chapter motion. But before I discuss the next topic, here is a query from one of the students who has sent me an email. He asked what is the full form of SI, which I have been discussing so far about the units. Students, it is an internationally accepted agency that takes care of different units for fundamental quantities. It is taken from French Système International des Unités. Translated form will be International System of Units. As you can see here, S and I, which I have indicated in the reading, so that is a self-explanatory for the full form of SI. The important thing to note over here is that this system of units is internationally accepted across the globe. For example, this is hand span, which in Hindi we call as bitta. We cannot accept it as a universal unit because my hand span will be different from others' hand span. So different persons will have different hand span and therefore it cannot be accepted as a proper unit. So this is about the query. Next, today we will discuss about two new concepts regarding slope and area under a curve. These are very important concepts. Let's see them one by one. Let me first introduce the concept of slope. You can see on the screen I have drawn a linear graph. This is x-axis, this is y-axis, and this we take as origin. Suppose we wish to find what is the slope of this particular graph. For finding slope, the first step is to see 2 points on the graph. Let me name them as A and B. From these 2 points A and B on the graph, will drop perpendiculars on x and y axis. So let's drop the perpendiculars. This is the perpendicular on x axis from A and this is the perpendicular on x axis from B. Suppose the coordinates of these 2 points A and B, you know about ordinate and abscissa. So for point A, the coordinates are suppose x1 comma y1, and likewise for point B the coordinates are suppose x2 comma y2. We also drop perpendicular on y-axis from these 2 points. This means for point A, this origin to this point, this is its x coordinate for point A and this is the y coordinate, you know this. So this must be x1 and this will be y1. Likewise for B, this should be x2 and this should be y2. When I say x1, I mean this length. This length is x1 and this length is x2. This length is y1 and this length is y2. To find slope, what we do? We complete this triangle, which is right angle. This is right angle triangle and we name this point as C. See the triangle ABC carefully. It is a right angle triangle and angle C is how much? That is 90 degree. Now slope, how do we define? Now slope is defined as slope is equal to, in that triangle ABC we divide BC by AC. In fact, this actually in mathematics you have not read till now. Suppose this angle I write as theta. There are 6 trigonometric ratios. Just to remember for the time being, that is referred to as tan theta. If I produce this graph, it will meet the x-axis and these two angles will be same. Why? Because you can see this x-axis is parallel to this line AC, this is transversal, so these are pair of corresponding angles, so they must be equal, that is theta. The slope of a straight line is defined as tan of angle theta, where theta is the angle made by that line with x-axis. Now what is the meaning of tan theta? Let me tell you separately. Suppose this is a right angle triangle, and in that right angle triangle I choose this angle as theta. Then you know, students, the side opposite to this angle is called as perpendicular, I denote by P. This side is called as base and the longest side is called as hypotenuse. Tan theta, don't worry about the name, it is simply the ratio of perpendicular to base. So P by B is our tan theta. Now can you guess here, if I have chosen this angle as theta, which is the perpendicular? It should be BC, and which is the base? It should be AC. Therefore our slope should be equal to BC upon AC. Now how do we find BC? BC will be equal to, you can see here, this length BC is this total length minus this length. So this total length, as we have seen, that is how much? Y2. This is Y2. And this length is how much, students? That is Y1. So this is Y2, this is Y2, and this is Y1. So this length will be how much? Y2 minus Y1. Likewise, for finding AC, you see, AC is same as this length. This length we can obtain by subtracting from this length, that is x2, this one, that is x1. So this is x2, this is x1. So this value will be x2 minus x1. So BC is how much? Y2 minus Y1. And how much is AC? AC is the same as this length, that is x2 minus x1. This is the meaning of slope. So therefore you can write slope, which is equal to tan theta, is equal to difference of y coordinates. So y2 minus y1 I can write as delta y by difference of x coordinates, that is delta x. If I have two graphs, see graph 1 and graph 2. This is y-axis and this one is x-axis. Looking at the graph, can you tell me, students, which of these two graphs has greater slope? You have to use same concept. For that you can see what angle does it make with x-axis. Suppose this angle is theta 1 and this angle is theta 2. We find theta 1 angle is less than theta 2 angle. You can compare these two angles. This has a lesser slope and this has a greater slope. The angle which is less, that, I should write this as theta 2 for graph 2, and this one I will write as theta 1 for graph 1. Then it reverses. Theta 2 angle is less than theta 1 angle. The graph that makes a smaller angle will have a smaller slope. Here we'll write slope of graph 2 is less than slope of graph 1. You can also understand this concept directly, that if you imagine an inclined plane, it's quite easy to perceive this, that if you sit over here, you will roll down, you will slip down. If you sit here, you will also slip down. But in these two cases, this will have greater slope because you feel as if you will slip quite fast over here. On the other hand, if you have a line like this, imagine there is a line like this. This is y-axis, this is x-axis. What about this line? If a person sits over here, will he ever slip? No, because there is no inclination. Here we say theta, the angle which it makes with x-axis is 0, and therefore we write its slope is equal to 0. So these are the concepts of slope. One more thing I can add here, the minimum slope is, of course we are discussing only for positive slopes. In class 9th that should be sufficient for you. So here this is the minimum value of slope. Now as the inclination increases, slope increases, and then slope will become maximum when the line will become perpendicular to x-axis. That I can take up here. Suppose we have x-axis, y-axis. What about this line? If somebody slips from here, it will slip very fast. So it has maximum slope. We say its slope is infinity. How much we write, students? Infinity. So here, when the line is parallel to x-axis, we say its slope is 0. When the line is perpendicular to x-axis, we say its slope is infinity, and otherwise it has some finite slope from 0 to infinity. So this is the concept of slope. Okay, let's see now some examples for slope. Here this graph is between position x and time t, and the graph is like this. We have to find slope of this graph. So as I have discussed earlier, we'll choose 2 points A and B, then we'll drop perpendiculars. So let us quickly repeat the method, and then we'll complete a triangle. We'll call this point as C. Then slope we have defined as tan of this angle. This angle will be alpha. Alpha is the angle made by this line with x. Here instead of x it's time axis. Slope we have defined as tan alpha, and that tan alpha I have told students perpendicular by base. It is just repetition of what we have discussed just now. Only one change is there. Instead of y versus x, the graph is between x position versus time t. So slope is BC by AC. Now tell me, students, what will be this BC? So this point is initial point A, this point is final point B. A initially the position I write as x1, and at B the position I write as x2. At A the time I write as t1, and at B I write the time as t2. Just as we have done earlier, here also you can see this BC will be this total length minus this length. This is x2 and this is x1. So this will become how much? x2 minus x1. Likewise, this AC is same as this length, and this will be this time t2 minus this time t1. So this parameter should be t2 minus t1. Therefore, you can put the value of BC and AC. So BC I'll write as x2 minus x1, and AC I'll write as t2 minus t1. So therefore, slope I can write of which graph, students? Position time graph. Position time graph I'll write as xt graph. Slope of position time graph is equal to how much, students? x2 minus x1. What is this? This is change in position. Change in position we can write as delta x upon, this is the time interval which we write as delta t. Now if we remember, what is delta x? Delta x is x2 minus x1. x2 minus x1, or final position minus initial position. If you remember the second topic that we have read in this, the first vector quantity which we have read in this chapter was displacement. Do you remember that? And displacement, how we have defined? Final position minus initial position. Instead of final f and initial I, we have final 2 and initial 1. So this is nothing but, student, this is displacement upon delta t is nothing but time interval. And what is the displacement by time that we have read? This is nothing but average velocity. What is this? That is average velocity. So this is a very important thing that you should remember, that slope of xt graph, it gives average velocity. I would like you to remember this important statement. Of course, we have discussed this for in context of a straight line, but even if the graph is not a straight line, even then always slope of position time graph, any kind of graph, will be giving you average velocity. Let's see one more case. Here we have a velocity time graph and we have to find its slope. Again we will follow the same method. We'll choose 2 points, students. Now I think you can do yourself also. We'll draw perpendiculars. This time I'll take as T1, this I'll take as T2. Here also we'll draw perpendiculars. Now these perpendiculars, their foot on v axis, velocity axis, will write as v1 and v2. Now let us complete the triangle. This point will be C. Now we can easily find the slope. Slope will be equal to how much, students? BC upon AC. Now as we have discussed here, quickly you can tell me what is BC. So BC will be this minus this, that is V2 minus V1. And what will be AC? AC will be T2 minus T1. So instead of BC, we will put it as V2 minus V1, and here we will write T2 minus T1. Of course, because it is making angle theta with x-axis, this angle is also theta, you can write slope is equal to tan theta, that is BC by AC is equal to this much. Now what is V2 minus V1? This is nothing but change in velocity by, this is time. So slope gives change in velocity by time. What is this factor to remember, students? It is just what we have discussed in the last class. Change in velocity upon time is nothing but acceleration. So this is your second important statement, that slope of velocity time graph, VT graph, gives what? Gives acceleration. You can add the word average also. So these two are the important things that you should remember. First one, slope of xt graph gives average velocity, and second one, slope of velocity time graph gives average acceleration. Okay. Next we would like to discuss area under a graph, taking example of velocity time graph in case of uniform motion. Uniform motion along a straight line we have already discussed, students. It will be that case in which the particle moves in a straight line, straight path, without changing its magnitude as well as direction of velocity. So in uniform motion, students, you know that the velocity is constant. It is constant in magnitude as well as direction. Whenever something is constant, it is not changing. If a parameter increases, then when we plot its graph, it should rise up, and if it decreases, it should fall down. Since velocity is constant in case of uniform motion, therefore the velocity time graph for uniform motion will be like so. This will be straight line parallel to time axis. If it is having, if the question is given that you have to plot VT graph for uniformly accelerated motion, the acceleration means velocity will increase, then velocity will be increasing linearly if acceleration is constant, or velocity may decrease also linearly. So the graphs will be like this or like this. Here velocity is constant. Let us see what we get on finding area under this graph. This velocity has a value, constant velocity v. This is the origin. Time starts from t is equal to 0, and at some point, say A, the time is t. From A we have dropped the perpendicular. It meets the time axis at t. Area under the graph means from time 0 to t. First to see where is the graph. From 0 to t, this is the graph. You don't have to consider the portion of the graph beyond t, beyond this time. Area under the graph means below that graph and above the time axis, what region is covered. So that I can indicate by this shaded region. This region which I have shaded, that is rectangular in shape. So what will be this area equal to? This area under which graph? Velocity time graph is equal to area of this rectangle. How do you find area of rectangle? Is equal to area of shaded rectangular region. Area of rectangle, you know students, it is length into breadth. Now this is the length and this is the breadth, or you can say this is the breadth. So length is t. This is how much? T minus 0, that is t. I can write t minus 0. And breadth is how much? V minus 0. So how much we get, students? This we get as V into t. Now let me remind you, students, velocity, you have idea about this, the average velocity. In case of uniform motion, the velocity remains constant, so average velocity is same as velocity at any instant. The velocity is given by the formula, if you remember, displacement by time. So this implies what will be displacement, students? Displacement will be, you cross multiply this, V into t. Are we getting V into t here? Yes. So therefore, it gives you one more important thing, that area under Vt graph, which is V into t, is nothing but displacement covered. It is displacement. And if it is one dimensional motion, then you know displacement and a distance will be same. So you might write it also as distance, but to be more correct, you should write displacement. So let me summarize what important things we have discussed so far. Okay, so these are the three important things that I have explained today, students. So slope of xt graph gives what, students? That gives velocity. Slope of Vt graph gives what? Acceleration. And area under Vt graph gives what? Displacement. So these are the three things which we have discussed so far. This is very, very important. I would like you to remember, and I should write here CTM, commit to memory. You should never forget. And one more thing, let me add over here. Although we have discussed three cases, these three examples, these three relations for a special case of straight line graphs, but even if the graph is not linear, even if it is some other kinds of curve, even in that case, all these three relations will hold true. One more thing, I can give you a clue. Whenever you are finding slope, in that case you have to find the ratio. It is xt graph. Slope means ratio, that means delta x by delta t. Slope of Vt graph means delta v by delta t. Now you can remember, delta x is displacement. Displacement by time gives average velocity. Delta v is change in velocity by time. Change in velocity by time is acceleration. So it is division. Slope means division, you can understand. Just for remembering, this is not the exact meaning. Likewise, for area under a graph, you can think of it as a multiplication sort of thing. For example, here you can think in your mind, you should not write like this, but you can think it is velocity into time. Here it was ratio, here it is multiplication. So since velocity is a displacement by time, therefore velocity into time should be displacement, which is we have written over there. So I will stop here, students. Next class we will discuss some of the derivations and also numerical problems based on slope as well as area under curve. So revise it properly and come prepared in the next class. I thank all of you and we'll meet again in the next class. Thank you.